What up, boys and girls? We are going to continue with I think it's the third episode of the blockchain of Blocker or UTXO model blockchain. And I think today is a good day, a good episode to start. Let me open up Proto actually. Types Proto. It's a good way to start mocking out or basically implementing our transactions, right? And transaction is going to be a very important episode because a UTXO model in blockchain, especially if you check the Bitcoin blockchain uses UTXO model, and there are a couple of others that are using that. It's a very, in my opinion, it's a very hard concept to understand completely. So we need to be, I'm going to try to explain it slowly, gradually, and we're going to make it more complex as along we go, or whatever you're going to say that. So basically a transaction is going to exist out of inputs and outputs, right? So let's, first I'm going to try to make these types, these messages in protobuffer, and then I'm going to explain along the way. So we're going to say message, and we're going to call this a TX input, like this, and we're going to have the pref TX hash maybe. And it's going to be, let's say it's bytes. It's going to be 1. Just like that. Then it's going to basically be the hash of the transaction of the previous transaction, right? Then we're going to have the UN32, and that's going to be the pref index. And that's actually the previous index of the output of that transaction that we want to spend. But I'm going to think about a good name. Pref out index, I think. That's going to be a better thing. And in Bitcoin, you have something like V out and all that stuff, but I think it's not that clear enough to understand what's actually going on. Right, so we're going to say this is going to be the previous hash of the transaction containing the output we want to spend, right? And this is going to be the index of the output of the previous transaction. Transaction we want, actually I'm going to new line, we want to spend, right? And maybe it's spent with a T or spent with a D. I have no clue. Let me know. Not that good in that grammar, right? Because it's not my native language. So the previous, very important, because if you basically want to, I'm going to show you with an example because it's going to be hard to grasp right now. Then what we also need to do is we need to have a bytes of the public key, of our public key. Actually, why are we recapitalizing this stuff? There's no need to be. There's no need to be. So we're going to say public key. And that's going to be 3. And we also need a bytes, which is going to be the signature. Signature is going to be 4. 4. My hand's still cold, right? So the public key is going to be our public key, and then the signature is going to be our signature based off the private key, right? Cool, that's the input. Then we're going to have an output. We're going to say TX output. Yes, and that's going to be a little bit simpler. That's going to be the amount. It's going to be an, we could choose actually here. Depends, right? If you actually want to do it, let's make it a UN64. The N64 actually. You could use it a float. Depends on how you want to. Let's make an N64 and maybe later on a big int. But I think for this blockchain, we don't need to have that kind of a big. The way you would use actually big integers is so you can actually scale your make fractions of the currency you want to send, right? But in our case, we're going to make it simple. N64 does not need to be that big, and that's going to be the amount. Is going to be 1, and then we need to specify the address To we want to send, to who we want to send this, who we want to send this, not quite sure. Like I said, I'm struggling with the parlance here. And that's going to be bytes, right? It's going to be bytes, the address. It's going to be 2, right? I think that's fine. Maybe I forget something. We will see. And then we have our transaction. And our transaction is going to have a version. That's going to be, what are we using for version here? int32, right? So we're going to use it, same thing, same type, int32 of the version of the transaction. It's going to be 1. Because it could be that we later on are going to change some semantics, internal semantics of the transaction, and then we can specify a new version so people know how to decode and encode that stuff and handle it, right? A little bit of coffee. All right, so we have this version thing, and then we also gonna need to specify the repeated inputs, and that's gonna be a TX, actually, a repeated TX input, which is gonna be inputs, gonna be 2. Copy this, and you're gonna say the outputs. That's going to be 3. Yes. For now, that's fine. That's fine. Let's compile this. Make proto. Okay, all fine. Cool. So let's make, we have types here. We have block. Let's make a new file. We're going to call this TX or transaction, whatever you actually, let's make a transaction. Transaction.go. And then let's make a new one. New file. Transaction. Test.go. Right, so we're going to say package types. And then in transaction itself, also package types here. Boom. How are we going to do this? What's going on here? I'm thinking how I'm going to explain this in the best possible way. Let's do transaction test real quick, although we don't actually. Let's make a function here. Function here, real quick. We're going to say hash transaction. We're going to give this a transaction like this. It's going to be a proto transaction. What's going on here? My hands are so cold. It's crazy. It's proto transaction, and that's going to return us. What are we doing in block actually? Just a byte, right? That's what I was thinking. It's going to be just a byte here. And let's save this so we can import that stuff. Yes. So what we're going to do is the same thing. We're going to say that the bytes or the error is going to be PB actually. Let's copy this here. Like this. Paste it in. Close the thingies. We're going to say PB. Marshal. So we're going to first marshal this to bytes. This is the transaction. We panic, right? If R is not nil. We could actually say must hash transaction, but yeah, I mean, let's panic the error if we cannot marshal it. Normally, we should always marshal that stuff, to be honest, but hey, that's why I also make it a panic, right? And like I said, if you don't want to use a panic, whatever, change this to your likings. So then we have this byte, and then we're gonna just say something like the hash, and in our case we're gonna hash it one time instead of double. So we're gonna say SHA 256, and it's gonna be sum 256 of the bytes, and then we're gonna just return here the hash, and we need to specify it as a slice. And that's what we have, right? So we're going to hash a transaction. And maybe we should also make some helpers to create a new transaction because it's going to get complicated. But we cannot really already make a new transaction because we need to have access to our storage so we can fetch the previous transaction, yada, 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 and all that stuff. But hey. That's for later on. First things first. So let us open up real quick transaction test. transaction test like this. I'm gonna make a simple function here, test new transaction t testing.t, just like that. So basically what we're gonna do is we are gonna have inputs and outputs, right? So that basically means that in Bitcoin, if you wanna, for example, I wanna send 100, I wanna send, for example, 5 coins, right? But my balance is gonna be 100, right? 100 whatever, 100 tokens. Or coins actually, maybe. 100 coins, right? And I wanna send 5 coins to an address to AAA, right? What I need to do is I first need to create an input, right? And that input is basically, we need to specify, if we want to spend something, we need to specify the output of our previous transaction where we actually received coins, if that makes sense. But of course, because we don't have any previous right now, we're going to make it a little bit simpler, right? So if you want to make an input, in this case, so my balance is 100 and I want to send, want to send 5 coins to AAA. What I need to do is I need to make an input, right? And in this input, let's open up here types proto, right? So we need to specify the pref hash, which actually we don't have because there is no previous transaction, right? Because it's the first one, let's say. We also need to specify the previous the previous index of the output, of the previous output, which we also don't have, so it's going to be 0, right? And then we need to specify a public key and a signature. So our public key we know because it's our public key. So let's say, actually, we could make it like here. So first of all, we're going to say that the in, actually let's call it input, is going to be n proto, proto.txin, takes input, yeah, just like that. We're going to say that the pref hash, we don't know it. So what we're going to do is, let's just make a random one, right? We're going to say util random hash, just like that. The pref out index is going to be 0, right? And then we need to specify the public key. So let's first make a private key. I'm going to call this or pref key. So it's a little bit clearer what I'm going to explain here. So our pref key is going to be a crypto generate private key. And we need to specify the signature, but we don't have it yet, right? We don't have it yet because we didn't sign it already. So, but we already have our public key, right? So we're going to say public key. Actually, to be honest, what I want to do is, that's fine. It's perfectly fine. It's going to be the or pref key. Or pref key, public bytes, right? That's what we want. And now we need to make an output. Output is going to be an output. The input is basically telling us about ourselves. It's telling us, okay, what was our previous output we received? Well, because that's what we need to spend. Oh, beating up my own mic. And what is our public key and what is our signature? That's basically some info. The input is the information about ourselves and our previous receiving, so to say, right? I'm going to try to explain it as simple as possible. And the output is basically going to specify the destination of the coins we are going to spend, right? And the thing is, we need to spend the whole shebang. We cannot spend we can spend a portion of what we received, but we actually need to spend everything and use a change address. I'm gonna explain this. So the output is going to be an nproto tx output, right? And we need an amount, right? And in our case, we need to make I'm going to say output A or 1. And that amount is going to be the amount we want to send, right? And that's basically 5, right? We're going to say 5 coins. And let's make a destination. 2. Actually, let's call this from. Let's call this from. That's maybe clearer. The from priv key. Right, and this is going to be the to priv key. And why do we need the priv key? Actually, we don't need it, but we need it to derive the address. It's going to be a crypto generate private key, and we're going to say that the to address is going to be to priv key public address bytes. Something like that. That's a to address. And then we're going to spend here that the address is going to be to address, right? That's fine. And actually, to address, let's make from address. It's going to be from priv key, actually. From priv key, that's fine. So that's the output one. So we have 100 coins. We are going to send 5 to address. I don't know who it is. Maybe Bob, maybe Alice, who's telling us. But then we also need to spend basically the other resting 95 of the coins, right? So we're going to make an output 2, which is going to be, actually what we're going to do is we're going to copy output 1. We don't need to type that much. Boom, just like that. Output 2 is this one. And the amount is going to be 95, right? And the address is going to be from. We're going to send it back, right? We're going to send it back. So we received 100, I don't know, from a previous transaction or something, right? We want to send 5, but we need to actually completely spend the whole shebang, the complete 100. So we're going to send 5 to our destination. And we're going to send 59 to ourselves back. But we're going to send our whole balance, right? That's the name of the game, right? So then basically what we could do is then we could say that the TX is going to be end transaction, proto transaction, by the way. Proto open transaction, and that's going to be, the version is going to be 1 or something, I don't know. And then we're going to say that the inputs, as it takes, how do we call this? Inputs? Yeah, inputs is going to be a slice of the proto TX input. Wait, what's going on here? Wait, oh, this is crazy. It's going to be a slice of proto TX input. And we're gonna put the input in it. That's fine. Then we're gonna say that the outputs is gonna be a slice of proto TX output. And then we're gonna say we're gonna have the output 1 and the output 2. Right? That's our transaction. That's fine. So also we need to sign it, right? Do we have this the same in block actually? Sign block, right? So we're going to make the same function in transaction itself. So we're going to say, actually it can be a top. I think it's a very important function. So we're going to say sign TX actually, or transaction. Let's make it verbose. So we're going to say, we're going to have the priv key, PK. It's going to be a crypto private key. Private key, and then we need to have the TX, which is going to be a proto transaction like this, and it's going to return us a crypto signature. Signature. Do we have the right crypto actually? Nope, we don't. Now we have. Right. So what we're going to do here is we're just going to return PK sign. We're gonna sign. We're gonna sign the hash of the transaction. Hash transaction, and that's gonna be TX, and that's gonna be it. Nice. So if you go to transaction test, back again. Actually, what we could do. What we could do is make it actually better. Let's open up transaction. What we could do here is actually doing something like because we have a pointer to this transaction, we could actually set the signature directly. Or not? That's a question. That's a decision we need to make, right? Because right now we return a signature, but we could directly set, because we have, right? What you could do is this, right? You could say sig is going to be this, and then we're going to say tx inputs. The problem is then we need to specify this one, which is nasty in my opinion. Signature is going to be sig bytes. You know what I mean? I don't like that. Let's just keep it. Let's just return the signature, to be honest. And now we could do something like that. The signature is going to be signed transaction, just like that, and we give it our private key from private key, right? Because we send it, we need to sign it. We're gonna give it the tx, and then we could say that the output one is going to be but signature. What's going on here? It's going to be sig bytes. Something is wrong. Input, I mean. What am I doing? Input, signature is going to be bytes. And then we could actually print f, percent plus v, new line, this tx, and see what's going on. Do we have a verbose here? Yeah, we have. Pref tx says this is random stuff. We have the public key. We have a signature. It's completely set. That's fine. And then we have the outputs. That's good. That's good. That's good. So now I'm thinking, how can we verify this transaction? And we're gonna make it cleaner, right? Because this is kind of a nasty stuff. But it is what it is. In Bitcoin, creating transactions is not that straightforward. In Ethereum, it's much more easier. But in Bitcoin, it's a little bit difficult, a little bit more job needs to be done. But it's also more flexible because you can, yeah, it doesn't matter. I'm not gonna, let's keep it simple for now, right? Because if you have a ledger, nano or something, you could see that they basically continuously creating new addresses and distribute that, but the balance stays the same. Your balance will stay the same because what's going on? My dog is acting strange. But that stuff we're going to cover later on. I don't want to overburden you with a lot of stuff. I hope this is already clear, right? Right, that if we have 100 coins, we need to make two outputs, right? Two outputs. Right? Two outputs that we need to make. One output is 5 to destination. To the receiver. Actually, to the receiver, both receivers. To the dude we want to send. Right? And then we need to have 59 back to our address. Or address. Or some other address. You know what I mean? Some other address. You could basically make one transaction and send 5 to Alice, 5 to Bob, 5 to Foo, 5 to Bar, and then send the remaining back to our address. We could also send the remainder to another address of ours. It does not need to be the specific same address. It could be something else. It doesn't really matter. Right? It doesn't really matter. Do we have something that we can verify a transaction? Let me see. Transaction. Can we verify? Verify transaction. But verify transaction is not validate, right? It's verify. Let me quickly think. And I know it's a bit tedious that we need to specify that we cannot call these functions as a receiver on our struct, but that doesn't actually matter, right? That's maybe a boolean. Let me quickly think about this, to be honest. We could do something like We could have multiple inputs. That's the problem, right? I think we could do something like, let me quickly do this. Inputs 0. Let's do this. Underscore input range tx inputs. Then we're gonna say input signature. We cannot verify this. Don't we have a verify stuff? Of course not. We don't have that. Do we verify somewhere? Sig verify. Yeah, I see. I see what's going on here, because signature in keys is going to be the structure. Yeah, I see what's going on. It's going to be value bytes, right? So what we could do is, maybe we could make something like signature from bytes. And signature value is going to be B. The thing is, what I want is if len B is not equal to, do we have siglen? Signature len also going to be 64. And then we could do something like signature len. And we're going to say here panic. Not equal to 64 actually. I know normally it should be, I know. It's a bit scuffed. It's a bit scuffed, not gonna lie. Because this is actually hard-coded. Because we have this variable here, I know. Yeah, this is what it is sometimes. So bytes, we're gonna set that here. So we could do sig is gonna be signature, crypto signature from bytes, which is gonna be the input signature, right? And then we're going to say sig verify, and we're going to verify with the pub key. Now we need the pub key from bytes. Actually, is that? That's true. Pub key is here. We're going to say public key from bytes, B slice of bytes. We're gonna return a crypto. Actually, it's not true. It's gonna be a public key here because we're in the same file package. We also need to check, to be honest, but we're gonna return an public key. Damn, the key is gonna be, that's a problem. Can I do key bytes? Actually, we could do ed, not sign, ed public key. Can we do this? B. Yes, we can. That's perfectly fine. So that's gonna, hopefully it's gonna panic or something. Not quite sure. Let's see what's going on here. So we're gonna say, actually I want a panic here. If len B is not equal to pub key len, panic invalid pub blick key length. Yeah, that's fine. So first of all, we're going to say that the pub key is going to be crypto public key from bytes, which is going to be the sig. It's not the signature, it's going to be the input public key. And we're going to verify the pub key with the message, which is going to be a byte. And that's going to be the signature, sign transaction, sign transaction, TX, bytes. Is that true? Wait, what's going on? It's going to give us a signature, right? That's going to give us bytes, right? It's going to give us a signature. Okay, then we could verify it here, actually. Not sign transaction. What am I doing? What am I doing? So sorry. It's going to be hash transaction, actually. Hash transaction of TX, right? That's what we want. And then we're going to say if this one, we're going to return false. And in this case, we're going to return true. Right? That's verified transaction. So what we're going to do is we're going to range through all the inputs. Most of the time, if you make simple transactions, it's going to be one input and two outputs. A signature from bytes is actually a wrong thing. Signature from bytes. Small mistake. So we're going to loop through all these inputs and we're going to verify them. That's what we're going to do. Like that. Because basically the output is only valid if the corresponding previous inputs, if the input was basically verified, right? That's the thing. What's going on here? All right, so verified transaction. Can we test this? Transaction test. Assert equal t, not equal, true actually. Assert true. And we're going to say verify transaction is going to be the TX here, and that should be fine. Not quite sure. Clear. Make test. Okay, we failed. Should be true. We have a problemos. Assert true, verify transaction, that's false. Now we need to check why that is. Signature from bytes is the input signature and the input public key. That's true. Then we're going to hash the transaction. Ah, I see what's going on. I see what's going on. So there's a problem, right? So the problem with hash transaction is that we are going to hash the signature itself, which is not, we cannot do that. That's a problem. So basically, what we should do, right, the reason why, let's open up this transaction in PB so I can explain this real quick. Types proto. Right, so we have this stakes input, right? And to be honest, I think these two fields can be omitted from signing, although the public key is fine to have, but the signature cannot be, right? The signature cannot be because it doesn't need to be. The problem is that the moment we're going to sign a transaction, we don't have a signature. You know what I mean? We don't have that. The only thing we know is our public key, but we don't know our signature because we're going to sign it to get our signature. In this case, we do hash transaction, which basically will hash the whole shebang of the transaction, including the signature, which we don't have at the moment we're going to sign it. So what we're going to do here is some dirty stuff. What we could do is input signature is going to be null. Hopefully this is gonna... Now it's passing, right? The question is, what are we gonna do? Because basically, if we verify the transaction and the signature is gonna be nil, that's a problem. We need to actually set it back in, to be honest. We're gonna make a to-do here. Make sure we don't run into problems after verification, because we have set the signature to null. That's very important, actually. Actually, fix me, to be honest, not to do. Or to do. It's fine. Okay, cool. So that's basically kind of the transaction shenanigans, inputs, outputs, and a transaction. So of course, if we really want to make transactions later on, we need to have access to the previous. So if I'm going to send a new transaction, I need to have my previous transaction, because I need to find my output. I need to specify the output I want to spend. That's very, very important, because that's how we gonna track. Because there's actually no database, right? There is no database of balances, just like in Ethereum, right? Everything in Ethereum is getting stored in an account model, so we can just update the address, transition the state, and update the account balance, and then we know it. But in Bitcoin, there is no such thing as that. In Bitcoin, we basically gonna hand over our whole balance. Like my bank account is 100, so I'm gonna spend $5. So I'm gonna spend my complete 100, send 5, but send 59 back to myself. And at that way, we can completely track. If everybody does the same, we can completely track the total balance, and also the total market cap that coin has, right? Tokens in circulation, if that makes sense, coins in circulation. All right, I think that was the very good first episode based on the transactions, although we need to go back and do some stuff here and there, but I think that's going to be a good episode for now. So we have blocks, we have transactions. I think we are set to basically start making our server itself, so we can actually have some dopamine. Maybe we should make some helper functions to create transactions, but I think we're gonna do that at the moment we are actually going to make blocks and all that stuff, so we can put some transaction in. Then we're gonna make these helper functions. First things first, and we're gonna basically go back and adjust things along the way. Right? Thanks for watching. I'll see you in the next episode.